Hello, class. Miss you guys. Hope everyone is handling the quarantine well and everyone's healthy. So obviously, it's not the ideal situation, but we're gonna make the best of it, and we're gonna make sure that we keep on learning. We'll talk about um, Zoom and kind of meeting face to face, but for the time being, we're gonna try to do notes this way. And the nice thing about it is you could always just pause or rewind and make sure that you're understanding it. So this is the old notes that you guys already have, and it's under Schoology with Unit 7 1/2 notes for Objective 1. So we haven't moved on. This is the last thing we did, and I already kind of filled out what we had already done in class. So now I'm just going to kind of continue with this and go through all these examples. A really good strategy you could do is before you just watch me doing it, try it on your own, and then pause the video and then try it, and then check it again to see if you got it right. All right, so I'll kind of give you like little breaks in between. That way you know when to start and stop again. Okay, so if you remember from last time, um, when in doubt, list it out. This is one of the things I told you guys you could always do if you're struggling with exponents. So over here, if you're struggling with this, you can always just write out 4 n's and then another 7 n's. And if you count them out, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, so we know that this is n to the 11th. However, there is a shorter way of doing this. You could just use the rules, which tells us that it's really n to the 4 plus 7, which is n to the 11th. Okay, as I stated before, sometimes students get confused with those rules, and then they mix them all up. For example, we added the exponents here. But there's going to be some people that are going to add 7 plus 3 plus 2. But we know that there's no way that it could be correct because this is all multiplication. So one thing to help you with a problem like B is to rewrite it 7 times 3 times 2 times r to the third times r to the fifth times r, which is really the same thing as saying r to the first. And in doing so, we're going to, again, understand that this is all multiplication. So when we multiply it, 7 times 3 times 2 is 42, and r to the third times r to the fifth times r to the first is r to the ninth. Okay, for C, we have x to the fifth times y to the 0 times x to the eighth. One thing that I like to do whenever I see anything to the 0 power is, I just kind of cross it out because I already know that it's going to be 1. So there's really nothing, to worry about and nothing to get confused about. So now we're just focusing on x to the fifth and x to the eighth, which is x to the 13th. Now, unlike the previous problem, here it's 5 times x to the 0. So the only thing that's being raised to the 0 power is the base of x. So that 5 that's just your coefficient, so it's just 5 times 1, which is 5. All right, so here I like this, that all the multiplication symbols are clearly stated. We know this is a multiplication problem. Now, when you apply the rules, or the shortcut, as some of you guys like to say, we know that we just add the exponents, right? But if you're still struggling, that's okay. Just list it out. X, 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 Y, 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 Y. So we have 3 X's and we have 11 Y's. Okay, now again, if you're struggling with this for E, you're struggling with this, again, some people will say, well, didn't you just add everything last time? No, I didn't. I added the exponents. Okay, but this is still multiplication. So this one way of helping you with this, so you don't make mistakes, is by writing it 5 times negative 12 times 3 times x to the fifth times x to the first times x to the first times y to the eighth times y to the fifth. I don't know why they changed that to 0. Okay, so this is a good strategy. It's kind of like rewriting it, so to combine in like terms, and that way you can clearly see all the terms that go together. So here are all your x terms, here are your y terms, and here are your coefficients. And we're just multiplying these out. So 5 times negative 12 times 3 is negative 180. X to the fifth times x to the first times x to the first is x to the seventh, and y to the first times y to the eighth times y to the fifth is y to the 14th. So again, you know, feel free to, like, before I start every problem, feel free, if you want, to just pause it right now, try it, and then check back and see if you got it. So let's try A. This is a different problem, but again, it's the same idea. When in doubt, list it out. So here I have m to the 12th, so that's m times m times m times m times m times m times m times. So you can kind of see it gets a little tiresome to write all of those m's over m times m times m times m, but we know that there is a shortcut that does exist. It's a rule that works, and that's m to the 12 minus 4, which is m to the 8th. So over here, again, the big confusion with B is that some students are like, well, didn't you just subtract those numbers? Yeah, I subtracted the exponents. But this is 16 divided by 32. I'm not going to subtract that. I'm going to divide it. Okay, so it's 16 over 32, which is 1/2. And that's y to the 4th over y to the 7th. And again, we're going to get into negative exponents here. But if you write it out, and we do our, thing of canceling, right? We have no y's on top. They've all been canceled. And the idea of canceling is you're dividing. So it's y divided by y divided by y divided by y divided by y, and 1 times 1 times 1 times 1 times 1 is still 1 over 2, and then this is 1, 2, 3 y's in the bottom. So it's 1 over 2 y to the third. Now, I have seen students in the past, like, they'll magically put the 2 into y cubed on top. But if you're just, being consistent and paying attention to your details, you don't have to do that. Okay, over here, let's try C. So we have a few things going on. We have multiplication and division. But if you notice, all your like terms are actually on the other side of the fraction bar. So we have a cubed over a, b over b to the fifth, c to the ninth over c to the fourth. And again, applying those rules, this is just a to the 3 minus 1. This is b to the 1 minus 5. And this is c to the 9 minus 4. Now, 3 minus 1 gives us a squared. C to the 9 minus 4 is c to the 5th. And b to the 1 minus 5, that's b to the negative 4th power. But we kind of know already from the next objective, which we taught together, that we cannot have negative exponents. That's just like a rule. I didn't make the rule, but I do enforce the rule. And we have to fix this negative exponent. So the question is, well, where will this negative exponent be positive? And it'll be positive in the denominator. So we get a squared c to the 5th over b to the 4th. Now, part of the reason why this works is because if I were to list it out, I get 3 a's on top, a b and 9 c's on top, over 1a, 5 b's, and 4 c's. So again, why are we allowed to do this? Why are we allowed to take a negative exponent and just move it to the denominator? Well, the reason is because if you list things out, we have 2 a's that are left in the numerator. We have 3 b's, 4 b's in the denominator, and we have 1, 2, 3, 4, 5 c's in the numerator. So that's how the negative exponents work. Okay, let's try D. So again, it's not 12 minus 2. It's 12 divided by 2. So this is going to give us 6. A to the 5th over A is A to the 4th, and B to the 7th over B is B to the 6th. Okay, so
They're still working on division?
No, they're not doing division. It's exponents. All right, so now here, again, when in doubt, list it out. So you could rewrite b to the 14th 6 times 1, 2, 3, 4, 5, 6, and then write b then 14 times in each of these, and then count them all up, and there's nothing wrong with doing that. However, we know from the previous page that if we're raising a power to a power, then we are allowed to multiply those exponents. So if I'm raising b to the 14th to the 6th power, that's the same thing as saying b to the 14 times 6, which is b to the 84th power. Okay, now over here, for part B, a lot of students, they kind of say like, well, isn't this kind of like distributing? Yeah, it is, but be careful. Remember, you're distributing to the exponents. So it's 3 times 13, and the exponent on A is 1, so this is 3 times 1. This is A to the 3rd times D to the 39th. Okay, over here, this is the same idea. We're dividing, that's okay. So it goes 3 times 2 and 3 times 7, which is p to the 6th over q to the 21st. Okay, this works the same way. A big mistake students make here is they say, well, look, all Mr. Vassar did was he multiplied 6 times 14, and all he did here is 3 times 13, and all he did here is 3 times 2, so isn't this 2 times 2 times 3? No, it's not, because I multiplied the exponents. So the exponent on 2 is really a 1 here, so this is 2 to the 3rd, a to the 12th, which is really 8a to the 12th. So be careful. That's one of the most common mistakes, is to say, well, all you're doing is multiplying. No, I'm not. I'm multiplying with the exponents. So be careful with that. So do yourself a favor and just put a little 1 on the number, on the constant, so that you know I'm not multiplying 3 times 2, it's 1 times 2. So this is 3 to the 2nd, a to the 8th, b to the 2nd, which is 9a to the 8th, b squared. Over here, I would simplify first before I apply this power here, right? I mean, like, the order of operations still does apply. So parentheses does come before exponents. So what's going on in the parentheses? Well, we have 6 times 2, so that's 3 b to the 4th over c squared, which is 3 to the 3rd b to the 12th over c to the 6th, which is 27 b to the 12th over c to the 6th. All right, so that's like the 13-minute mark. I think YouTube has a limit. So I'm going to stop for now. This will be part 1, and we'll continue in part 2. All that means for you guys is just go on to the next video. Okay.